In today's episode, we will be covering IDEs and syntax. So how do we write code? It's not like we can simply type words into a text document and automatically assume that the computer can read it. As we talked about in the previous episode, the code must first be converted into machine code, a series of zeros and ones which the computer can then interpret and carry out to complete a certain task, like opening up a browser or a game. And additionally, we can't just write rubbish in the certain programming languages mentioned in the previous episode and expect the computer to understand it. So how do we do this? This is where an IDE comes in hand. An IDE stands for Integrated Development Environment and allows the facilitation of code by a computer. IDEs provide a graphic interface on which your computer can easily write, run, and debug code without having to worry about problems with compilation or interpretation of the program. Think of an IDE as any other program on your computer, such as a game or a browser or even the File Explorer, except we'll be using it to write code. Additionally, IDEs provide some useful tools for programmers to ease the job of writing code, such as built-in error checking, hotkeys for frequently used functions, and class hierarchy, which comes into play when talking about a specific type of programming known as object-oriented programming, which we'll talk about later. IDEs are sort of a way to fast-track writing code and make things a whole lot easier on programmers, which is why they're so popular. An example of a specific IDE, known as NetBeans, can be seen on your screen now. In the center, you can see the program that is currently being written, and right below it, the console, which can print out useful information for the programmer. The specific IDE is used to write Java code. IDEs are extremely powerful and will be used for the majority of tutorials on this channel. So through these IDEs, we are finally able to write and compile code smoothly without worry of the computer being able to understand it. The next problem we then run into becomes how do we write this code in the IDE? It's not like we can simply type in random words from a specific programming language and expect the compiler to understand it fully and completely. Now, just as if you were learning a real language, learning a computer language can be very similar. Some have different layouts that may seem odd, some may take on abstract or weird processes which may be confusing, and like all languages, programming languages have a set of rules that you must follow when writing code in that language, and at the forefront of these rules is the programming grammar. Programming grammar is referred to as syntax and is very similar to real-world grammar. Each programming language has its own syntax or rules that you have to follow to a T if you want your program to run correctly, just as if you were speaking in real life. These can be things such as how you define certain variables, what you put at the end of the line of code, and how you use certain functions. Each language is unique in its own way, and while some may share similar rules or syntax, all will have a quirk which makes it stand out from the rest. Syntax is something that catches a lot of people off guard, since many expect each programming language to follow the same set of rules. But as we spoke about in the previous episode, because each language is specialized for a specific task, each needs its own set of rules to function. As an example, let's say we wanted to do something simple, such as initialize a variable, which is something we haven't covered yet, but the example is still relevant. In Java, you'll notice that we have to specify what type of variable we are defining, in this case an integer, and also add a semicolon after the statement is completed. In Python, we don't even need to define that we are trying to make a variable. We just need to type in the name of what we want to create. And in JavaScript, we just specify that we are making a variable, but not include what type of variable we want to make. Even in this specific example, you can see how much syntax matters when learning a new language, since while the goal of our program remained the same, define an integer with a value of 3, all the programming languages shown took different approaches to this task. All these languages require that you follow this syntax because remember, computers are extremely dumb. If you forgot one semicolon or misplaced a single character, the entire program will not run and send you back a syntax error, which is something we'll talk about in a later episode. Think of this as if you forgot a comma in a sentence, and the entire context of what you were trying to say gets misinterpreted, like in the common example, "Let's eat, Grandma." If you forgot that comma in the middle of the sentence, while it may seem like such a small mistake, it changes the entire context of this, making it sound like you're about to eat your grandma, which is not good. The same rules follow for programming. If you forget a semicolon, the entire context of your program could be corrupted. Now this is another thing which makes IDEs so useful, is that they will let you know if and when there are syntax errors in your code. Syntax errors are part of your code which don't follow the rules we talked about previously. The IDE will tell you where in your code the error is, and would even not let you run your program until the error has been fixed. Because of how important syntax is to writing code and learning a new language, It's recommended that you learn the rules and know-hows of a programming language before beginning to write high-level programs in that language. Most of the rules are tedious to learn but easy to master, and as soon as you can do that, you'll be able to easily identify syntax errors and take care of them easily. Next time, we'll finally jump into some code with print statements and talk about how and why we get information from the computer. If you enjoyed this video, consider subscribing. To the left, you can see our last video on what programming is, as we take you through a basic tutorial on the fundamentals of computer science. If you'd like to view the whole series, the playlist is linked to the right. Thanks for watching.